In this screencast, we are going to design a function that creates a line chart to show stock prices over time. As you can see, we have been given a data definition for a list of floats, an example list of stock prices from Google, and if I scroll down, a fully designed function that takes an integer and returns a list containing the integers from 1 to n. Let's start by understanding the code that we've been given to work with. I'll start with the data definition. The first thing I look at when I'm reading a data definition that someone else wrote is the data type definition and the interpretation. Those pieces of the design are enough for me to know what I have to work with. In this case, a list of floats. At this point, I may also look at the examples so that I know how to form data of this type. But in this case, I think the data type definition and the interpretation are sufficient. I do not read the template now. If I am designing a function that takes a list of floats, I'll read the template carefully at that point. For now, I just need to have a high-level understanding of the new data type. Now I'll look at the function design. I know that I may want to call this function, so I need to understand what input it takes, what output it returns, and what it does. The signature and purpose should give me that information, so I'll start there. Okay, this function takes an integer and returns a list containing the integers from 1 to n. Often, the signature and purpose are all that I need to read when I'm looking at a function that I may need to call that someone else has designed. However, the examples can also be helpful. Maybe after reading the signature and purpose, I'm not quite sure what value this function would return when given a particular input. The examples are a good way to check. Note that I am not reading the body of the function. As a programmer who may want to call this function, I do not need to understand how the function is implemented. I just need to know how to use it. Now that we have a sense of what we've been provided, let's move on to the problem we need to solve. We need to design a function that creates a line chart of stock prices over time. As always, we'll use our How to Design Functions recipe and start with the stub, including signature and purpose. We've got an example of stock data for Google, and can see that it's stored as a list of floats. So we can use list of float as the input type. Our function will display a line chart and return none. For the purpose, we can state that the function is displaying stock prices over time. This is fairly general, as we don't know if the stock prices will be daily, weekly, monthly, or on some other unit of time. If we had more information about the input, we might be able to write a more specific purpose. To finish the stub, we need to write the body of the stub, so we'll write return none. The next step is the examples. For visualizations, it's most useful to hand draw the examples so that you think through what you want the plot to look like. I've already hand drawn an example and I'll insert it into my notebook. I'll start by creating a new cell and then changing that cell to be a markdown cell. Once I've done that, I can use Insert Image from the Edit menu, choose my image, and once I run my cell, I can see my example. As you can see in my example, I included all the labels as well as a rough picture of what a plot might look like. I also want to write at least one expect. It won't be able to check that the plot that's created is correct, but it can check that none is returned and that the function runs without errors when called with appropriate input. I'll run my code and I see that I don't get any errors. The next step is the template, and we don't really have a template for a visualization function. At this stage, I find it useful to look at another visualization example of the same kind of chart so that I know what I need to include. Here I've opened the line chart worked example from Canvas, and I'm going to use this to remind myself what I need to include in this line chart function implementation. Scrolling down, here I have the function definition, and I can see that I need to set the labels, the x-axis label and the y-axis label, and the title. And I see a call to axis, but I know that's optional. If I want to set the axes endpoints, I can, but PyPlot will do that for me automatically, and hopefully it will do a good job. Usually what I do is try designing my function without a call to axis, and then if the axes seem off, I set them myself. I can also see that I need a call to plot. There's also code here to set properties for the line, and that's optional as well. You only need that if you want to change some properties for the line, such as the color or the kind of marker. Then we need to show our plot and return none. First, I'll comment out the body of the stub, and then I'll write the labels. I also need an appropriate call to plot. So now I need to think about what to pass to plot. I'll double check my example to see what my x values are and what my y values are. I see that time goes on the x-axis, so the range of times need to be my first argument to plot. I remember that I have a getRange helper function that is already designed, and I think it will be useful here. I'll check the signature, purpose, and examples for getRange to confirm. Yes, it seems useful. I will put in a call to getRange, and I need to give it an integer to specify how long I want the list to be, because it will return a list from 1 to n. And what I can use there is the length of the stock prices. If there's 10 stock prices, that will give me a list from 1 to 10. If there's 90 stock prices, it will give me a list from 1 to 90. The next argument is my y values, and those are stored in the parameter stock prices. I'll put in my call to pyplot.show and return none. Now I think I'm done, so I'll run the code to check. And I can see that it runs without errors, and I do indeed get output that matches my example.